Integration by substitution. We have 3 steps to this method, and then we're going to go through an example. So the first thing that we will have to do to integrate using the substitution method is to find a function u which is a function of x. And we'll show you how to do that in a minute. Second step is to calculate dx by du, and the third one is to look at the limits if it's a definite integral. So the example we're going to have a look at, just change colour, is the integral from 1 to 3 of 1 over 1 plus 2x dx. That up. So we're going to pick our u to be 1 plus 2x. If we pick this function for u, then that will simplify our original integral enough that we can integrate easily. So now we've done number 1, we'll move on to 2. So we want to find the derivative of x with respect to u. So first of all, we're going to find du by dx, which is going to be 2. So that means that dx by du is going to be a half. And we can write this as a half du, almost as if we were multiplying by du on both sides. Now we've just got to have a look at the function. We've done that step. So 1 over 1 plus 2x, because of how we've set u, is just 1 over u. The final thing before we put it all back into the integral is the limits. So here our x limits are x equals 1 and x equals 3. We want to find out what the u limits are, so we put them into the original function of u. So 1 plus 2, u equals 3, and u equals 1 plus 6, which is 7. So back to the integral, we can integrate from u equals 3 to 7. Of 1 over u times by a half du. And just so you can see where this is coming from, we've got the limits coming from over here. We have got 1 over u comes from here, and then the half du comes from this line here, where we swapped it out with dx. From here on in, we treat this as a normal integral, so I'm going to take the half outside of the integral sign. So we've just got to integrate 1 over u du. I make that ln of u 3 and 7, sorry. Which is going to be a half ln 7 over 3. And that is integration by substitution. Hope you found this useful.